This podcast is brought to you by Flipper, a marketplace to buy and sell websites, stores, and digital real estate. Plot your own path. Become a boss by buying a small online business at Flipper. Simply visit flipper.com/techtalks for a free consultation and 50% off fees. That's FLIPPA, flipper.com/techtalks. If you do visit, let me know how you get on. But now, let's get the show started.
Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast. I hope you're all well, and thank you so much for the kind emails and messages about me losing my dad. It's been a rough couple of weeks, but a big thank you to each and every one of you for tuning in and giving me that sense of purpose to keep busy and jump out of bed in the morning. And I've got to admit, one of the things that I love about recording this podcast every single day is learning more about the technology that surrounds us all, but most of us are completely blissfully unaware of. For example, Lidar technology and Lidar modules are used for shuttles, commercial vehicles, robotaxis and so much more. But today I'm in a bit of a learning kind of mood, so hopefully we can learn a thing or two together today about Lidar technology from my new friend France, who is the president and COO of LeddarTech, which is the developer of Lidar, a proprietary Lidar sensing technology that is revolutionising object detection and ranging. And they're also experts in mobility. And today's guest is an absolute joy to speak with too. So buckle up and hold on tight so I can beam your ears all the way to Montreal in Canada, where France is waiting to speak with us now. So a massive warm welcome to the show. Can you tell the listeners a little about who you are and what you do?
Yeah, my name is Franz Nicolini. I'm President and Chief Operating Officer of LeddarTech. LeddarTech, we are a sensing company. We develop environmental sensors, including LiDARs, but we are more what we call a software company that has a suite of SoC system on a chip that we leverage as a core acquisition technology to acquire signals from the environment. And then we use signal processing library software to process those signals so that we can detect obstacles and objects within the scene. And that is used in autonomous driving, in ADAS applications, as well as robotics, smart cities, smart factories. And we also have an application layer of sensor fusion perception stack that really allows more intelligence. So we fuse radar, LiDAR, camera feeds, and we do essentially the fusion stack, and we process that, and that allows for perception stack. Why is that important? Is obviously ultimately all sensor modalities have to be fused to create intelligence for the vehicle, not just to map the environment, but to also make decisions as far as path planning, mapping, scene understanding, and driving decision.
And to get everyone listening on the same page, especially because we're talking about some incredibly cool technology here, can you tell the listeners a little bit more about exactly what LiDAR technology is for those people that have not heard about it and where they would typically encounter it without even realizing?
Yeah, great question. I mean, LiDAR, typically most people would be familiar with either cameras or radars. And radars are radio frequency, essentially. Data acquisition mechanism. And so they use radio frequencies and then they process that radio frequency. So typically you'd have an analog front end together with a radio and some processor. Then LiDAR is the same approach, but using light technology, typically lasers. You could have what we call near infrared, which is 905 nanometer lasers, or you could have 1550 longer wavelengths, and both of them are used essentially to flash the scene. We use LiDAR to map out the lunar surface. So the Apollo mission, they use LiDARs to actually map out the lunar surface. And then in the early 2000s, DARPA, which is basically the defense and army arm of the United States, which usually looks at very advanced projects. They're the inventors of the GPS system. They did this context to use to advance autonomous vehicles, and then they did a competition on basically having autonomous vehicles run a specific obstacle course, and that's when LiDAR, all the vehicles that actually finished the course had LiDAR, and that made LiDAR very popular in autonomous driving. And then from then, a small company out of California called Google started their special projects, or the Google X project, which was now become Waymo, which is the autonomous driving. So if you encounter a Waymo vehicle, you'll see all these spinning buckets or spinning turrets. And there's this company also out of California called Velodyne that actually become famous because of this DARPA challenge. So they're sort of the most popular company in the LiDAR space because their LiDARs were used by a lot of the universities, but also a lot of the innovative startups in the world. And so you can find LiDARs in all sorts of applications, like for speed enforcement, or tolling system, intelligent tolling system. So if you go to places like Korea, Japan, China, we have these tolling systems. They use LiDAR, and the reason why they use LiDAR is because of greater precision than, let's say, a camera or an infrared sensor. Precision in terms of accuracy, but also in terms of the resolution. So why is that important? If you're running a tolling system, for example, if you miss a motorcycle, or if you miss a car, or if you know it's a car, but you can't tell that it's a truck, so you're not able to charge properly, and that costs a lot of money. And so you need 99.99% accuracy in order to be able to charge properly. And so that's one of the most commonly used. The other is marine. So these large boats, these cargo boats or these cruise ships, they have radar on board, but they also have sonar and LiDAR. And again, you want to be able to, if you're in these large, gigantic tugboats or these large cargo boats or cruise ships, you want to be able to see the techno-obstacle kilometers away, because that allows you to actually plan for the course better. And having multiple of these sensing mechanisms, from GPS to sonar to radar to LiDAR and even camera, just makes these safer.
And on the side of autonomous vehicles, do you have any use cases or examples you can share around LiDAR modules for shuttles, commercial vehicles, and robotaxis? Because this is where it's all coming to life, isn't it? It's not just something that's going to happen in the future. It's already there. That's
correct. In fact, we see a lot of use cases where LiDAR is used already in applications such as mining, construction, and forestry. And the reason why is because the cost of human tragedy is high. It's also, these are harsh environments where it's difficult to have human beings, operating 24/7. And so they use these autonomous vehicles there. And so essentially we're starting to see these now very popular in agriculture. Again, harsh environment, difficult to operate, and also for their lower cost than having human beings, running these operations. But then more recently, we started seeing applications such as transit or shuttles, or even more recently, autonomous delivery vehicles, smart factories, where you're using robots in dark warehouses or dark factories to be able to operate safely 24/7. And so these are areas that are geofence, so controlled environments. There is, very little human interaction besides safety, for safety or technicians. And so it's an easier use case to start with, rather than going to full passenger car, which the conditions are far more complicated. The course is not private, or it's not known, and it's more difficult to predict what will happen. And so the beauty of these applications, it allows car manufacturers or fleet operators or even factory operators to learn and in an environment that's safe for humans, and that allows us to actually learn and develop more complex use cases and eventually apply them to automotive applications. And the first passenger car automotive applications will be for ADAS, so advanced driver safety and assistance and systems. So what you will have are things like highway pilot, traffic jam pilot, or autonomous valet parking, or even things like city pilot in the future.
And a question I've got to ask, of course, is what are the biggest hurdles to mass adoption? Because I think that always seems to be the biggest key to the success of any technology, and it's always the hardest step to master, isn't it?
Yes, for sure. I mean, the first thing is there are four factors. The first factor is performance. Performance meaning that these systems have to be able to perform under any circumstances all the time. And they have to perform better than a human being. And so in that case, to be able to model for all the potential use cases that human beings have developed over millions of years, it takes time. It's complex. And so the way, as they say in this African saying, the best way to eat an elephant is to slice it into pieces. And so therefore, in autonomous driving, you have to slice the problem into use cases and then work these use cases one by one. That's the safest way to do that. And you need to be able to have performance, and performance vary depending on the use case. And so if you're in a level 3 application for ADAS application where you're doing a traffic jam pilot, well, you've got to be able to model all the traffic jam use cases that you would encounter and all the risks associated to that, and then simulate for it and test for it and validate and do it that over and over, millions and millions of different cases. And so that takes time to achieve. The second problem is you've got to be able to do that performance at low cost. And so, today an autonomous driving system, a full autonomous driving system, would probably cost $300,000. And the biggest part of the cost is the sensing. So the sensor suite is expensive, and the biggest expense out of the sensor suite is the Lidar. And like you said, Neil, it's a chicken and egg kind of situation, because you need volume to lower the cost, but you also need performance and to be able to achieve that. And so, but you also need cost to come down for people to adopt in more volume. So it's a bit of chicken and egg equation, but we will address the cost situation, no problem. For this to achieve mass adoption, the autonomous driving system has to be around $5,000. That includes the sensors, the cameras, the radars, the LiDARs, as well as the GPS, the IMU, and the autonomous driving software. Fully tested for $5,000. And that's when you're going to start seeing mass adoption. We're probably a few years away, 3 to 5 years away from achieving that. The third element is automotive grade quality. So all the LiDAR sensors and autonomous driving systems that we're seeing today, they're more commercial and at best industrial grade. They're not yet automotive grade quality. And in fact, LiDAR sensors have not yet achieved automotive grade quality. LeddarTech is probably the only company out there that's shipping a solid state LiDAR in any meaningful volume today. Most companies don't have a solid state LiDAR, and even worse, they don't have an automotive qualified LiDAR yet available. This is probably a couple of years away. We're going to start seeing the first automotive grade LiDARs on the market probably in 2022 and 2023. And these they're not just automotive grade, they have to be functionally safe, meaning that they have to have some level of functional safety and redundancy. And so they have to work. They can't fail. And so they have to have fail-safe mechanisms. And so the automotive grade is a big challenge because it does take time and it also does add cost as well. And then the final element is scalability and flexibility. Scalability, not just in being able to produce them in high volume, scalability also in the context of flexible according to the use case. So the issue today, if you have a front long-range LiDAR, and that's good for highway pilot, but then if you go into a traffic jam pilot, you need a side and corner LiDAR that is also working at lower speed and shorter range. And so most LiDAR companies today have built, if they built a front long range, they have to redo it all over again if they want to do a side or corner. And that's not scalable because the cost of developing a LiDAR is so prohibitive. It takes so much time. You need a platform approach that allows the car maker to scale up from the highest end product, let's say an S class, all the way to a C class, down to a C class, where they may not have the same performance requirements because they can't charge that much for a luxury car, but they still need to have the flexibility to adopt the same platform, the same software, the same technology from highest end to mid end to low end, and not having to redo all the tests, redo all the validation, repurpose again. And so, these 4 factors are what's limiting the industry today, but we are extremely close, Neil, to achieving this 4 threshold.
I've had countless emails from listeners over the last few weeks talking about their fears and concerns around job security, while also seeing their interest rates on their savings drop considerably. And as a result, many are beginning to look at how they can invest in their future in an uncertain time. Could digital assets be the answer? Now, you might remember that I spoke to Blake Hutchinson, CEO at Flipper, on episode 1194 about how to buy digital assets and websites. In a nutshell, Flipper is a marketplace that you can buy and sell websites, stores, and digital real estate that are just ready to go. So if you do have dreams of running your own successful online business, or perhaps you're looking to exit your existing online business, my friends at Flipper can help you buy and sell. So if you're interested and want to find out more, please visit flipper.com/techtalks. That's FLIPPA.com/techtalks for a free consultation and also 50% off all fees. But now, back to the interview. And of course, as you continue to progress forward, you're going to be leveraging other emerging technologies as well. So I'm curious, what role do you think artificial intelligence will eventually play in all this too?
It's an essential part of the solution. So, Yeah, we already use artificial intelligence from, machine learning to computer vision. And one of the critical role of artificial intelligence is the basically autonomous crunching of data. What I mean by that is, an automotive is essentially, let's say, whether it's camera or radar or Lidar, is generating tons of data that needs to be interpreted. And to be able to do that efficiently, you need the machine to be able to learn how to recognize obstacles independently, and how you have to teach it to learn. And whether that's computer vision or machine learning languages, so you have to be able to do that. And so AI is critical, not just in the sensing side, interpreting the data, but also in making decisions as far as what's going on in the scene, what is the intention of the other vehicle or the pedestrian, predicting when the street light is going to change color, or making a decision in a complex situation when, turn left, turn right, change lane, slow down, accelerate. So no question, artificial intelligence is an essential piece of that, and we use that today in sensor fusion or in perception stack.
And from the outside looking in, it seems almost like a combination of the LeddarTech, the Lidar platform, and the role that the Lidar ecosystem plays in this, and also the mission that you're on is incredibly exciting too. But can you expand on all that for people listening, just so they can visualize this mission that you're on here and how all this comes together?
Yes, indeed. So remember, we talked about these 4 key elements that are necessary to make for mass adoption. So performance, cost, automotive grade, scalability, and flexibility. Well, to do that, we have to have partners that are working in collaboration. We can't be experts in anything. Making a LiDAR or an autonomous driving system is extremely complex. And one company cannot undertake that on its own. In fact, you're seeing that today, even large companies like Waymo or large companies like Volvo are joining forces. You're seeing Ford joining forces with Volkswagen. You're seeing, Aptiv joining forces with Hyundai. You're seeing Intel, Mobileye partnering with almost everyone. And so, these ecosystems are essential to have each partner working on critical elements or critical components where they're experts and they can go deeper in each of these segments to achieve these performance, cost, quality, and scalability and flexibility that's required by the industry. But also by working together, we're setting a roadmap. So essentially, we're telling the industry where we're going to be 5 years from now, so that everyone can follow that standard, can develop according to that standard. And so what it does, it basically, democratizes the use of these technologies and give reference designs to people who need and who will have intention of using them, and also guarantees that there will be life, after each of the individual companies move on. So in other words, today, LeddarTech is a small company. If you're Ford, GM, or VW, or Mercedes, relying on a small startup company that's working on its own in a vertically integrated model, that's high risk, especially considering the complexity and the huge liability that's associated. But having ecosystem partners, extremely successful and large companies working together with us on our platform, that gives the security that these tier 1s, tier 2s, and OEMs need, but also the safety net that they need in order to deploy the technology across the board. And so it's an essential part of the evolution of the industry from going to independent startup working independently to companies working in collaboration. That's always been the case in automotive. Companies have always collaborated, and this autonomous driving is the same.
And your passion for this technology and the opportunities ahead really shines through. But I'm curious, what is it that really excites you about the future of LiDAR technology, and also the role that you think it will play in all of our futures?
Yeah, I mean, if you think about it, LiDAR has is necessary for autonomous driving to be successful, but also for changing the way people interact with their vehicles. And I think, when you fast forward 10, 15 years, 20 years down the road, making the road safer, but also giving people back their time. How much time is spent on the road, burning miles and kilometers and burning time. So all this time can be taken back, but also cost of ownership, owning a vehicle. It won't be necessary to own a vehicle. You can, buy miles, you can buy kilometers, or if you own a vehicle, you can have it operate. Instead of owning two vehicles, maybe you only need one, and have them, the one vehicle operate more efficiently. And so this has the impact, the potential to change the way people interact, the way mobility is used today, but also on future generations as far as a greener and more safer environment. And so I'm quite delighted to be part of this. And I think LiDAR is one of the essential technologies that's changing the way we operate a vehicle today. And actually the whole artificial intelligence as well is impacting and democratizing this technology, because it's going to make it cheaper, lower cost to operate a motor vehicle, and safer and greener as well.
And I think if we go back just 6 months ago, if I ask any business leader what their plans were for the year ahead, I'm sure it would be completely different to what it is right now. But so I'm curious, what is your primary focus at LeddarTech now, and obviously for the year ahead? And has anything changed around where your focus has been because of the global pandemic?
Yeah, you're absolutely right. No one could have predicted the severity of the situation and the impact on the global economy. If anything, for us, this has further consolidated our strategy, and it helped us, really validate some of the plans that we had. And if anything, we feel better about our plan today than we were prior to the pandemic. And the main reason for that is we are executing on a product roadmap. We are operating in a financially sound way. We are generating revenue. We've been generating revenue for several years now anyways, since we're one of the oldest LiDAR companies out there. But we always had as a strategy to be a environmental sensing company, starting from a base of LiDAR. If you look at Mobileye, they started from a base of camera to become essentially an autonomous driving company, an ADAS system supplier, and now a mobility as a service company as being part of Intel. We're not going to go as far as being a mobility as a service provider, but we are a full-scale, ADAS and AV environmental sensing supplier. So offering end-to-end open platform, scalable architecture that is hardware agnostic. We're basically accelerating that and bringing more products into the market. And we're also well positioned to be a consolidator because we are executing on a few acquisitions. In fact, we're just a couple of weeks away from making an announcement of an acquisition that we're in the final stages of closing. And we are also looking at other acquisitions. So we are accelerating the rate at which that we are developing through some, acquisitions, stuff that we had planned to do 3 years from now. We're pulling that in because we see an opportunity to do it now. And the pandemic has really is weeding out the noise and helping the whole industry to focus on what is important, but also taking out the weaker players who are creating noise, because a lot of startups, particularly in the LiDAR space, have been funded over the last 5 years, which has basically created noise and also raised the lack of confidence of the maturity of the industry. And so fast forward a year or two from now, only the strongest companies will survive, and that's going to facilitate adoption. And also at the same time, it also allows us to focus on the real use cases that really matter, that are going to deploy. And so if you look at the pandemic, it's accelerating autonomous driving solution, advanced robotics, smart cities, smart factory, commercial and heavy industry. You're seeing companies like Amazon buying Zoox recently. The main reason for that is essentially they feel that, autonomous driving is necessary to really help them scale to the next level. And so we agree with that. Autonomous driving, commercial delivery, and heavy industry, shuttles, automated ground vehicles are going to deploy over the next 3 to 5 years. And that's going to generate significant income, but also going to position us for the next wave of adoption in the passenger car, which in our minds will happen in 2024, 2025 timeframe.
And for anybody that's really interested in LiDAR technology and the future opportunities and how it's going to be ingrained in almost everything we know in our life without even realizing it, what is the best way of finding out more information there and finding you guys online and contacting a member of your team? Could you point them in the right direction? Yeah,
the best way is to LeddarTech.com, Google LeddarTech, that's LeddarTech.com, or you can just type LiDAR. I'm sure we will be one of the first companies that come out there. But the best way to learn is really to use the web. Google is a fantastic vehicle. It's the online library. There's so much information that's accessible via the web, from webinars to technical to as well as to more business practical videos. And so there's a ton of knowledge that's out there, and and it's easy to access it.
Fantastic. Well, your passion and enthusiasm for everything that we've talked about today really shines through, and it's a subject that I'm going to be delving a little bit more into because I'm really curious on where this is all leading. But more than anything, just a big thank you for taking the time to come and speak with me today. Thank you.
Pleasure, Neil. Thank you for having me.
I loved hearing a little bit more there about LeddarTech and the LiDAR platform and the mission that they're on over there, including the role played by the LiDAR ecosystem, because I don't know about you, but I learned a hell of a lot today. But more than anything, I think France stole the show because he is a great guy who I could have chatted with for hours and officially added him to my cool guys I'd like to share a beer with. But any comments from you guys and dolls listening about LiDAR technology and the work that they're doing at LeddarTech, please let me know. Email me, techblogwriter@outlook.com. Remember, my website is techblogwriter.co.uk. You'll find links to my social channels and over 1,260 interviews. Man, that went quick, didn't it? So, hopefully you'll join me for another 1,260 episodes over the next few years. But more than anything, I just want to check in and say thank you for listening. And until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.